This is question 10 on that midterm. It says list the amplitude, period, phase shift, and vertical shift, then graph this thing. Well, remember, it's amplitude, trig, whatever the function is, bx plus c plus d. D is the vertical shift. The vertical shift here is 2. So it always helps when you're graphing secant and cosecant, just graph sine and cosine, and then draw in your peaks between the asymptotes. The asymptotes wherever sine and cosine hit the midpoint, midline, that's where your asymptotes for secant and cosecant go. So normally cosine is on the x-axis. This one shifted up 2. So here's the midline. Draw in your midline. Midline. And in fact, I'm going to draw the cosine function in yellow. You can draw it in very light pencil and then draw your actual secant function in pencil so that it's clear, and then erase the other one. I'm going to draw my cosine in yellow so that we can easily differentiate it. So there is no phase shift. Why did I put 2 up here? That 2 doesn't belong there. 2 is the vertical shift. I want that in black. The vertical shift is 2. And I got to get my pen. The vertical shift is 2. The phase shift is none. There is no phase shift. There's no C here. And remember, the C over B, when you have it in this format where the B is not outside of the parentheses, when it doesn't look like this, then what you actually have to write to shift it over is C over B is what you have to write in there to shift it over C. But this one has no phase shift, period. The period is 2 pi over B, and what does it say here is 3, so 2 pi is a normal period for secant, and it's going to be 2 pi over 3 is the new period for this one. So 2 pi over 3. Let me erase some of this so I can turn this into a white area to do more easy work on. So 2 pi over 3. Normally it's 2 pi. 2 pi over b is going to be the period 2 pi over 3. So we have to draw our end point where the period ends, and then the midpoint, and then the 2 points in between those. Well, it says 2 pi over 3. So this is going to be one of them. I'm just going to mark them here. And then here's the mid one in between them, pi over 3. And what is that? Pi over 6 and pi over 2. So that's pretty good. You could also do this. If you know what the b is, usually cosine is 2 pi, pi over 2, and 3 pi over 2. If you just divide all those by b, you're going to get what the new 4 points are. 2 pi over b. Well, in this case, b is 3. 2 pi over 3. The midpoint is pi over 3. Pi over 2 over 3 is pi over 6. 3 pi over 2 over 3 is 3 pi over 6, which is pi over 2. So those are your 4 points. That's where things are happening. All right, what does cosine look like? Well, again, there's no change in amplitude here, excuse me. All of a sudden, I have a stuffy nose, which may be good, it may be bad, but it's annoying. Excuse me very much. Excuse me. Okay, that's better. So normally, cosine starts one above the midline. There is no change in amplitude. I want to do this one in yellow. Let me get yellow. One above the midline, right there. And then it goes down at the first point to 0. Then it goes to the minimum at the middle point. Then back to 0. Back to the midline. Then back to the top point. Then back to the midline. Then back to 0. And we can keep going like that. So once you've drawn one place, you can just keep drawing the graph. You have to know what cosine looks like. You have to know what sine looks like. This one looks a little bit strange. It should be right there, should be the 0, but you get the picture. And then the asymptotes, and I'll draw these in black pen because they have to be dashed lines. The asymptotes are wherever cosine hits 0. So there's an asymptote. There's an asymptote. Should be right on that line. I have a hard time seeing this. Let me zoom in so I can read those. That's pi over 2, 2 pi over 3. Yeah, so those asymptotes are in the right places. And then this one goes over here. Ugh, I just zoomed in. This one goes over here. The next place it touches 0. And then another asymptote is here. Another asymptote is there. You get the picture. It should be right on that line. Negative pi over 2 and so forth. And then you can just draw the graph in. It's just like an upside down or right side up parabola that touches the high point and goes between the asymptotes. Wait a minute, I don't want it to look like a circle. And by rights it should approach but never touch those asymptotes. And that's it. You've just drawn this graph. And I do the best I can. I'm no artist. You have to do the best you can. You're no artist. But that's it. It looks like that. And it goes on forever. And then you can erase this yellow part if you don't want to see it. So that's how we get this one. Secant 3x plus 2 using our standard transformations. Draw our 4 points, the end of the period, the midpoint, and then the 2 points between the origin and the midpoint and the end point. Or you can take the original 4 right there and divide them by b, and that gives you your new 4 points. Then put those on the graph. Make sure you shift up the vertical shift. Make sure you handle the change in amplitude, which in this case there was none. And you've got it. And then you can draw secant or cosecant or sine or cosine. There it is.